So I have, because I can't help myself, even after all these years, I have way too much content. And so just to tell you beforehand, I will skim over some things, but I thought better to leave it in because we're recording for posterity, and there's a lot of hyperlinks in there that we won't explore now, but that I hope people can go back and look at after the fact. A little, I guess really the other only context, I certainly don't consider myself an expert in open science. I guess I'd consider myself an advocate of open science, someone with a lot of interest in open science, and someone who is exploring conducting meta research on the degree to which we need open science, the effects of open science, and it is something as I kind of, I guess, transition into, I want to say the latter stages of my career, something that I've just become really interested in. I think it's kind of inherently interesting, but something really important that cuts across really all areas of research and scholarship. So I come at it from a very broad perspective, and I should have probably silenced that. Where I think where I first got started in this, I don't know why I would have been reading it, but probably 7-8 years ago now, I read a piece. John Ioannidis, who is up at Stanford, a medical researcher, does a lot of meta research, and he, in addition to an MD, he has a Ph.D. in math, and he wrote a paper which I think is still the most highly cited paper in PLOS, the Public Library of Science, which is kind of the big success story for open access journals. And he wrote a paper called Why Most Research Findings Are False. And it is basically a mathematical proof showing that different types of bias and under different conditions, most of our research findings, especially the positive findings, are probably false positives. And to the degree that I could make heads or tails of his mathematical proof, that actually makes a really strong argument. And I had really devoted my professional career to identifying and trying to disseminate and facilitate adoption of evidence-based practices. So things that we've shown on the basis of sound research to work. And so this idea that, well, maybe the research isn't everything we think it is, really made me take a step back and think about things. And so I am still a dyed-in-the-wool empiricist, and I don't want to get into, so I'm going to suggest we don't think about research or put it on equal footing with other ways of knowing. I really do think we need to let research guide our policy, or at least inform to some large degree our policy and practice. But I think we need to be as open and transparent as possible with our research to improve the quality, the efficacy, the impact, the trustworthiness of our research. So that's where I got going with all this. All right, open science, nullius in verba. I like to use a little starter sometimes phrase, and it makes me look smart when I can use Latin. So I did that. And so I'll touch on that in a second. A little preview, we'll talk about what open science is. I will endeavor to not spend too much time on the culture of modern research and problems in the research enterprise. A, because it's depressing. B, because I can spend a whole lot of time doing it, and then we won't have time for the more positive stuff about what we can actually do about it. But then we'll talk about some of the primary reforms associated with open science and end with just a little bit of challenges and questions in thinking about and talking about implementing open science, and then end up with some directions that seem to be taking place in scholarship and research around implementing and adopting open science. And through all of this, let me know questions and things. I'm happy to stop and pause and spend more time or provide a little background. So what is open science? Is I think it's the next slide we'll look at. Open science is a very broad umbrella. So it's difficult to kind of define in a simple way. The definitions that I like best talk about, at the heart of open science, it's about transparency and opening things up. And that can be about how we disseminate research and information. It can be about how we plan our research and studies. It can be about the data that come out of our studies. But at some level, all of these aspects of open science are about transparency. So it's making the entire research enterprise, kind of from soup to nuts, as transparent as possible. And that facilitates research being more efficient, more verifiable, increases the validity or the trustworthiness of the research and the impact of the research, hopefully. So I've been fortunate to, I put on my opening slide, I totally forgot I was, but I'm officially an ambassador for the Center of Open Science, which means I filled out a form on their website. And
now you're formal.
Yeah. And now when I did it, I was really nervous about it. But I don't know if I should be an ambassador. That sounds pretty important. It's not a big deal. And they were right. It really isn't. But I do. It happens to be right down the street from where I moved. It's a professor from University of Virginia, Bryan Cook, who started it. And so I do a fair amount of work with them. And so we were working on a paper recently. And I said, I like these kind of opening phrases. And I said, there must be some catchphrases around open sciences. This is a good one. Nullius in verba, which is the motto for the Royal Society, adopted in the 17th century. And so this is what you kind of started codifying how we do science in the modern age. And so their motto is essentially take nobody's word for it, which I'm way back when in the day as an undergrad, I was a philosophy major. So, and unfortunately, that makes you virtually unemployable. So I ended up going into education, but I still have a little bit of a philosophical bent. So I like take nobody's. I think that in some ways is the essence of science, including science. We shouldn't take scientists' word for it either. And so this is about opening up the books on science. And I think there are some issues. So as Winston Churchill once said, democracy is the worst form of government out there, except for all the rest. I think science is the worst way of knowing out there, except all the rest. You know, it really does have some issues in it. And this isn't a panacea. It's not going to cure everything. But sunlight said to be the best of the disinfectants. And so this is in some ways opening the books of science, trying to let sunlight into the scientific process as much as possible. And it isn't going to cure everything, but I think it's going to help clean it up. So we'll talk a little bit more about that. So this is just a graphic that I like, and it shows all these different areas, and I don't think it's exhaustive, but just to give you an idea of these different areas. Open access, a lot of people will think of open access as open science, but there's a lot of other elements to it, from just opening your notebooks while you're planning and conducting research to opening data. One area I'll probably touch on very briefly, but open peer review that I find fascinating. Open source, which I know is something that you all are discussing. And there's a citizen science aspect to all of this too that allows everyone to participate in science by making the means and the products of science as open as possible. So a lot of different directions out there around open science, which we'll touch on many of them today, but not all of them, and not all of them in depth.
Pedagogy there too. That's another area we're looking into.
I'll talk to you later. We'll talk afterwards about exactly what that looks like. So I don't want to spend much time on this because for a variety of reasons, but mainly because it'd bore you. But I remember reading, I think it's Francis Merton, but the Mertonian norms of science. And these were, Merton was a sociologist, and he really studied kind of the culture of research. And when he started to look at research, even in the 30s and 40s, saying this doesn't work exactly how it should. And so he postulated that science should operate based on 4 norms to really be as meaningful and productive as possible. So it should be universal. And so it's the idea, ideas, findings don't get privileged by titles or positions about who conducts the study, that everybody should be on the same footing. It's the scientific merit that really matters. something he called communism, which often now gets talked about as communalism. But he originally at least called communism. But it's the idea we're all sharing this stuff. We're all working together on things. It's about a community of science. It's much less efficient if we work in silos and independently and from each other. Disinterestedness, for this to work, we have to cultivate disinterestedness. If you have stakes in your research, which I don't think we can remove this, we're human beings, but it's one of the things in Jill and I's field of special education. I think we walk a fine line between advocacy and researcher. And sometimes that's celebrated, and I think it's helped the field in many, many ways. But I think it also has some real dangers. And that if you are heavily invested, even if it's just philosophically, but certainly financially, in the results of your research, that's going to affect in very, well, sometimes not so subtle ways. Sometimes people make data up. But I think more often it affects how we do work in subtle ways. And then an organized skepticism, that we don't just accept things on one study or because it sounds good. You got to have data. You've got to have data that is replicated. So Mitroff got these counter norms popularized. And Mitroff actually did a qualitative study of the scientists behind the Apollo astronaut missions and studied them and observed them and said, as opposed to the Mertonian norms, he observed scientists that were involved in secrecy, particularism, self-interestedness, and organized dogmatism. That they were actually, and in some ways, it actually pushed them. It was one of the drivers to this kind of competitive nature of it. But they were very secretive, and this is mine, and they were very deeply embedded in their own positions and theories and backgrounds, and they were in competition with each other about which one was right. Anderson did a series of surveys afterwards and found that while most scientists highly agree with the Mertonian norms, they agreed with verified Mitroff's qualitative findings that most people say, but in reality, the counter norms are much more prevalent. And so that's psychology. This is exploded in psychology more than in any area for a variety of reasons. We'll talk about some of the replication studies and the replication crisis in psychology mostly. But there was a glut of findings that kind of didn't make sense, and that studies weren't getting replicated. And there was a real concern, but there's evidence of this in other fields too. Brian Nosek, starting in the early 2010s, was doing work and really looking at academic culture and said, I like this quote that he's used in different forms in different presentations and papers. Scientists are reinforced for getting it published, not getting it right. And we've got to fill up our CVs with not just publications, but it depends on where you are, but publications in high impact factor journals. And that's really the coin of the realm. And to get those papers published, there a psychologist named Geiner Sorolla wrote a paper that I really like, and he talked about the pressure to produce papers that were aesthetically pleasing. So in our field, Exceptional Children is kind of the big journal. You get some papers in Exceptional Children, you're pretty set up career-wise. They publish 24 articles a year. They get 250 submissions roughly per year. Not too many get in. Oftentimes one of those issues is going to be a special issue. So really it's 18 articles a year. If you have a paper with loose ends that, there's quite a few limitations, it just isn't going to get in, even if it's a good paper. And so there's this press too, and I don't think I think most researchers and scientists are not actively fabricating data and just making stuff up, but they're making subtle choices that they're probably not entirely aware of too. Well, maybe I won't report that part of the study. Maybe I will, well, and we'll talk a little bit more about this, but this press to, if the incentive structure is such that got to publish in these types of journals and the rejection rate is very, very high, you need to produce studies that look a certain way that are going to get accepted. And the other thing is that emphasizes you just don't see replications with null findings published very much. It is studies with positive findings, and there's a high prioritization of novel, interesting findings. So that's it's how we've kind of evolved in terms of the research culture, but it's kind of a recipe for disaster in terms of if we're all out there looking to get positive, novel, interesting findings in terms of trustworthy research. So this is, I should check these results. It's publish or perish. There's actually some studies that say there's a just shocking number of statistical and reporting errors in studies. And that at a very basic level, you get the findings you want. No, why are you going to go check everything another time? You did it right the first time. If you didn't get what you want, you're probably going to check that and see, well, look, there was this is entered wrong. I could do this a different way. It's just, I think, just a good example of how it's not exactly falsification, but it is nudging or massaging things in the wrong way. So this is the replication crisis, and this is a non-example of how you should organize the slides. I kept adding information more and more, just one more bullet point. I do want to throw in that quote, but to hit the highlights. So replication, key part of the scientific process. We shouldn't be basing policy and practice on the results of any one study. There's error in any study, random error, systematic error. We need to see findings replicated, ideally multiple times to really kind of trust our findings. And yet we don't do much replication work. Makel and Plucker and have done a series of studies, and the first was in Psych, and they said 1% of publications in the top 100 Psych journals are explicitly replication. So they said this is a replication study and did a replication study. They replicated this in education, 0.1%.
Oh my God.
So 1 out of every 1,000 articles published in the top education journals. We did that in special ed, and we found about 0.5%, so a little higher. I actually did a review that said, I don't care what you call it, I'm just going to look at all the intervention studies I can find, and do they look like replication studies? It was a really hard review to do because, I ended up phrasing it, we have a lot of replicative studies. Almost everything we do in the literature review says, and the other researchers have done this, so I'm going to do something similar. It's replicative-ish, but replications get kind of a bad reputation. They're that's boring. You're just doing what somebody else did. And we don't do direct replications. We do things that are kind of sort of based on something else, but there's a big press on, but it has to be novel. It has to be something different. And so there is this sense we know a lot of things, but we don't know much real well because we're always trying to push the frontiers of our knowledge and find out new things instead of really finding out what's going on. Open Science Collaboration replicated 100 psych studies. They did these really well, made sure the replications were highly powered, that there's open notes and open data on all this stuff, and it's been reanalyzed many, many different times. It's a great example of open science at work. Of the 100 studies, 97 of the original studies, statistically significant findings. Replications, 36 of 100 were statistically significant. Mean effect size in the original study, 0.4, slightly under 0.2 in the replication, so half the effect size. So it's this idea when you've got non-interested folks replicating a study versus interested folks who are trying to get this published in the top journal, very different findings. So Kammerer et al. Successfully replicated 13 of 21 studies in social science. Klein et al. 13 of 21 social science experiments that have been published in Nature and Science. Klein et al. Did a study called Many Labs 2. It's fascinating. Click on the hyperlink and take a look at it. But they found 14 of 28 high-profile psych studies. Ioannidis started this off in 2005 by showing that he found replications that other folks had done of the most highly cited medical studies. And he found roughly a third of them replicated, a third of them didn't replicate very well, found different findings, and about a third of them had never been replicated. And so are kind of these unchallenged findings that we haven't verified so much. This is a piece in The Atlantic that Ed Yong has done on this so-called replication crisis, and said, ironically enough, seems one of the only consistent findings that we have is that the inconsistency of replication in psychology, that about half, and so they've done many of these kind of large-scale projects now, and across disciplines, although there's some variation, it tends to be about half. Publication bias is the other kind of really scary piece out there. Null findings. This is the file drawer problem. The idea that I'm all excited to do this research. I do it. Oh, the intervention didn't work. I'm going to put that in the file drawer. And the file drawer problem was coined in the late 70s, so now it'd probably be the hard drive problem. I'm just going to file that away on our hard drive. And we do know, and there's been more and more research, this is a bigger problem than we thought. So at one level, we just see the scarcity of null findings in the research base. So this is across different disciplines. Finelli found that 86% of hypotheses tested in the literature were confirmed. It's actually highest in the social sciences, well above 90%. In psychology, it's about 95% of hypotheses tested are confirmed. Null findings in a different study, least common in social studies. So there's two ways this plays out. Publication bias, we just don't publish those studies at all, or not at all, but infrequently. So they followed, and there's many different studies like this, but this one I thought was a good example. They followed up some NSF-sponsored programs that were funded. And of these different surveys in the social sciences, 10 of the 48 or 48 of the surveys got no results. Only 10 of those ended up being published. So the vast majority of them were unpublished. As opposed to the surveys with strong statistical positive results, the majority of them ended up being published. And what they ended up interviewing the researchers, and they found that the majority of the studies with null findings, it wasn't that, and there is evidence that editors are less likely to accept studies with null findings, but it appears kind of a double whammy. Not only is it less likely that they're going to be accepted, people are just less likely to write them up and even submit them for publication. So oftentimes there's just no chance they would see the light of day. If we were doing like I'm teaching a doc seminar in this right now, so now would be the time where we would pause and discuss why would that be. But I think there is, and because we're trying to get through this in less than a semester, I think there is different motivations for people. I think for the most part, we don't research things that we're entirely neutral about. We have ideas about it. We wouldn't be researching it if we didn't have theories and ideas. And when it doesn't work out, I think sometimes we're just disappointed. Maybe people are worried about, but I'm doing a lot of training on that. I don't want that out in the literature that it might not work. I think more often there's this sense of no study is perfect. And when you recollect, those findings aren't right. Those null findings aren't right. I don't want to publish that. It's because there was something else going on at that school. I chose the wrong outcome measure. There's something that I think it would be a disservice to put that out. And so we're just going to shelve that for now. My guess is that's what's going on. This other type of or kind of variation of publication bias is outcome reporting bias. And so this is when we do a larger study, but that the publication only then reports certain findings. And so this study out of education looked at 621 dissertations. 79 of those ended up being published. The statistically significant findings from the dissertations were 141% more likely to be reported than the non-significant findings, comparing of the 79 published studies, comparing the dissertations to the studies. Oftentimes the non-significant findings were just left out of the literature. And so this has some implications when you read journals.
Yeah, I mean, I just wonder, thinking about our junior faculty, how many are publishing because they feel like they're really contributing to a knowledge base, and how many are publishing just to publish to get it out there to meet their tenure requirement? And it changes your framework of what you want to put out there if you're just trying to get it out there. But you don't see yourself part of this larger community that's building knowledge.
I think that's right. And so one of the things I go back to is my example a lot. I was never taught this, but somewhere along the line, I remember living in fear during my dissertation that I wouldn't get statistically significant findings. And I thought that was a failed study. I didn't even know if I would get my Ph.D. if you didn't get statistically significant findings. I just had the sense that that's what was important out of it, and it's not. And that wasn't the topic of a course, that you have to get statistically significant findings or it doesn't count, but somehow I inferred that from, and I do think that it too often, not all the time, but I think too often the message is you've got to get it published, and it's about building your CV, and it's a heck of a lot easier to get novel statistically significant findings published than replication studies or studies with no findings. But those are important to science, and that's important to get the full. If we really want to know what works, we have to know what doesn't work, and when and where things that do work don't work. That was poorly said, but I think we need to identify the boundaries of effectiveness too. And if there's this big chunk of the research base that isn't getting published, it's really a hole in our research base. Yeah.
I was just going to say, as a reviewer, a journal reviewer, the guidelines of many journals ask the reviewers, is this making a novel contribution to the field? And that's one of the criteria you're asked to rate it for. So there's a sort of presumption that if they don't, come up with something new, that it's not worth publishing.
Yep. So I just did a review of journal websites and policies in our field of special education, and there's just a few, but I don't think they were there a few years ago, that a few of the journals are now saying we welcome replications, and they'll be reviewed in the same way. We welcome studies with no findings, but it's still rare, and there's still a lot of journals that explicitly ask you to comment on making an original contribution. And I do think it's hard because they're in the business of getting citations and selling journals. And so I understand why they do that.
Selling journals.
That's right. But they shouldn't. That's right. We don't have to be in the same way anymore. So I've reviewed a few times for the Public Library of Science journals, the PLOS journals, which are open access journals. But they also, and they're entirely online, they explicitly say, we don't care if you find this interesting or novel. If it's good science, we're publishing it. And I reviewed a paper that I thought, I guess there's nothing wrong with this, but I just, this is really boring to me. I don't see how this makes, and I had a hard time, and I think I did revise and resubmit reluctantly, and ended up getting published. They don't care if you find it interesting. If it's good science, they'll put it out there. And it's this whole other side of this where who are we to say what's interesting or not? And if it's good science, it should be out there, and let the public or the future decide whether and how they're going to use it. So this is just a graph from one of those studies talking about looking at the increasing incidence of positive results for hypothesis testing research across fields. So questionable research practices, I'll go through this quickly. Some things where I should have put this, I think there's a picture of this, a graphic of this somewhere, but it's like the Titanic thing where the iceberg and just the tip of the iceberg. These data fabrications, and in our field, Andrew Wakefield's research that's been retracted now, but making the link between autism and vaccinations, which has been proven wrong over and over and over and over and over again. But once it's out there, you can retract it, but it doesn't mean that it hasn't already had its impact. And that's a great case study of that. I think those cases get a lot of, just above the surface, those icebergs get a lot of attention, but much more common are what sometimes they're called questionable research practices. So things that aren't clearly just, oh, you can't do that. You can't just make up data. You can't lie about things. These are things that probably a lot of people do and that are really kind of on the border, but help kind of introduce some bias into our science. So Simmons, and I'll talk about a paper they did very briefly here. Research, they call these researcher degrees of freedom. We have a lot of choices at every stage of the research project about how to do our study. And if we have ideas about how we want, unconsciously or not, the research to find out, we're going to make those decisions in certain ways. So hypothesizing after results are known, or harking. You get all this data, you're playing around with it, and you see, oh, look at that. That's significantly related. That makes a lot of sense now that I think about it. My guess is half of the hypotheses that we see, I shouldn't say that, I don't know. But I know a lot are, and I've done that before, where I put it in as hypothesis, but it wasn't a priori hypothesis. And so I'll skip ahead here. It's easy to hit the bullseye if it gets painted on afterwards. That's not how inferential statistics are designed. You can't say it's statistically significant if you didn't predict the result beforehand. It doesn't work that way. But that's what we're doing. We're playing around with this spreadsheet of t-tests and ANOVAs or whatever you're doing and saying, oh, that one's significant. That makes sense. Concocting a theoretical rationale beforehand and making a post-dictive prediction, which is an oxymoron, but we're doing exploratory research and passing it off as confirmatory research, and that's wrong. And well, it's not, exploratory research isn't wrong. It's fine to do that, but you have to tell people that I fooled around and looked at like the 18 different ways to do this, and this one came out. That's a very different message than I predicted this and then collected data to test it, and we confirmed it. And that's how it's treated very often. Data peaking or optional stopping. I've got this data. I'm going to analyze it. Ooh, P of 0.07. I'm going to go get a little more data. Or P of 0.04. I'm not getting any more data. We're done. And so if you're checking as you go, you kind of, if data kind of come up and down, you're going to stop at the right time. P-hacking. It's one of my favorite things. It's real data from federal, from the presidency and Congress and financial data at the federal level, and you click enough buttons and you covary for different things, you can show that the Democrats are the best thing in the world for the economy, and you can show the Republicans are the best thing in the world for the economy. And so this p-hacking is just the idea, some data phishing, but you've got a large data set. They're liars, damn liars, and statisticians. That idea that if you play with it, you can find out almost anything with a data set. And so they've done a few studies of researchers in different fields about how much do you do these things. And so researchers admit to doing these things at a frighteningly high incidence. So this is one out of psychology. It was the first questionable research practice survey, and they found, for example, 63% of researchers admitted to not reporting all the dependent variables in their studies at least once. And so this is probably the ones that weren't statistically significant. 56% said they'd engaged in data peaking, and so on and so forth. And there's a link there. Fraser et al. Is the most recent one done in the field of ecology, but the findings are pretty consistent. So this is a study that they did computer simulations with, and so they said 4 questionable research practices. You've got 2 dependent variables that are moderately correlated. You get to choose whether you combine them, use one or both of them, and use them separately. You can choose to add 10 more observations per cell. You can decide whether to control for gender or the interaction of gender with your treatment, and you can decide as a researcher to drop or not drop one of 3 conditions. And so they found, looking at P of less than 0.05, the typical level, that any one of these is associated with about a 10% likelihood of false positive findings, which is a little frightening, but kind of makes sense. But you combine and someone who's doing all 4 of these, it ends up in 61% likelihood of false positive findings. So you do some of these, people admit to doing these things all the time, in part because they don't think they're wrong. They just think it's kind of being a savvy researcher. So you do all of these things to kind of massage and help you find what you want to find. You're probably going to find what you want to find. Gelman and Loken, I haven't read the book. I should sometimes because I refer to it sometimes when I talk. This is The Garden of Forking Paths. And so the book has nothing to do with research, but it's about that idea that life takes you along there are many different choices in life. And each of those choices leads to new choices. And each of those choices lead. And so where you end up at one point out here on a tree, there's an almost infinite number of different paths you might have taken that all started way back to a choice you made when you were very young that just took you on a different path. But they say this is what we do in any research study. And that when we report a study that's here, we may have not have done anything wrong, but we could have found something very, very different just by making other reasonable choices along the way. And that it is kind of a fallacy to present this is the answer to this research question. This is the harking thing that we already looked at. And so a couple quotes that I really like. If you torture the data long enough, nature will always confess. He was an economist. And a statistician, I just found this one, and it leads us. I liked it because now we're going to enter. So we're leaving the scary negative stuff behind. Going to get a little more positive about what to do about it. It's easy to lie with statistics. And so that's it's credited to Twain, but Twain took it from, I don't think there's clarity on where it comes from. It wasn't Twain's idea, but he kind of popularized the liars, damn liars, and statisticians. But it's easier to lie without them. And so we don't want to abandon all hope and say, well, there's problems. This is a bunch of nonsense. Just do whatever you want because research is worthless. So one last negative idea. So all of these things that we've been talking about, Ioannidis, who is the medical researcher, who does a lot of meta research in Stanford that I'm pretty fond of, he estimated based on empirical estimates of false positive findings because of things like questionable research practices, publication bias. He says there's a lot of false positives out there. And that we very rarely do replication studies to identify studies that are false positive. So he estimated, based on this research, that 53% of the findings in psychology are what he called unchallenged false positives. So they're false positives that have never been no one's tried to replicate to see if they actually are false positives or not.
Has anyone been looking at the impact? I mean, the autism one is clear. It's in all of our lives. But is anyone looking at the impact of some of the other ones? To look at, I think in education and evidence-based practices, RTI, the implication of things going to policy and being in practice very differently.
Well, I think it's a hard thing because we don't know that they're false positives. You can't identify unchallenged false positives until they're challenged and identified as false positives. So, and that's just an estimate. I tend to think it's not that bad. I think we do replicative research that isn't direct replication and maybe isn't referred to as a replication, but there are a lot of practices, right, that there's a lot of related research that we probably have a pretty good idea that it's actually effective. So I don't think it's as bad as some of those numbers seem, but I think there are a lot, and you look at dissertations, for example. People go do weird stuff with dissertations and never follow it up, and it's out there that oh, this works. Really? I don't know. That doesn't seem quite right to me. So hopefully we're not using that as the basis for policy and practice, but undoubtedly it does sometimes. And I think it's one of many problems we have around the research to practice gap, that when people question the validity of research findings, I think sometimes they have good reason to. I don't think they're questioning it for those reasons oftentimes, but I think there's something to it. It's not what I'm going to talk mostly about, but it is part of open science, and I know it's part of what you're discussing here on campus. So this other issues related to open science. That can't be right. Most of the research is behind a paywall. Here's a documentary movie. If you watch it, I had my students watch it. Half of them said, yeah, but it kicked me off. I said, oh, it's so ironic. It's behind a paywall. They make a joke relatively early on and say you have to pay $39 to do it or it's going to kick you off. And they panicked and shut it down. Or they didn't want to watch the rest and figured this was a good excuse. But it gets you fired up. Just
Oh, we might have to have a screening night.
I wish it was a little shorter, honestly. It gets a little repetitive, but some very good stuff in there. But it just makes no sense that all this research that is done through federal and state funding, then state and federal funded researchers pay through their institutions a king's ransom to be able to access that stuff. And one with the UCs, it's obviously a huge point that'll be interesting to see how all of that develops. Peer review, my general take on peer review is another. It's the worst system we have except for all the rest. There's really some issues with peer review that open science is taking up as well. So open science, I'm going to go through a handful of approaches that are at their heart transparent and open to try to address some of these issues that we've been talking about. Arguably the most fundamental one to me is this pre-registration. And so one of the sayings around pre-registration is that it's a plan, not a prison, because I'll explain that in a second. But the idea of pre-registration, so the way research is typically reported is you write it up and hopefully it gets published if you're lucky. But you're just trusting the researcher's report of that. And is that what they really did? Did they leave some things out? We really don't know. If they're bad at lying, you can catch that. But if you're good at it, or if no one really looks that closely, you don't catch things. So pre-registration says before you do your study, you've got to publicly register your plans. You got to say how you're going to do this study. And so there are registries now all over the place where you publicly upload, and there's different formats, and it's actually relatively easy to do. The easiest format, one on the Open Science Framework, is a blank page. You put whatever you want. Others are a little bit more directive and kind of give you boxes and prompts to fill in. But even going so far as the analysis, what analysis are you going to run with this? How are you going to treat your covariates? Really spelling all that out so you can't make it up afterwards, or you can't experiment as you go along and then say, yep, that makes a lot of sense to me. That's the right way. You have to spell it all out beforehand. So usually including these elements, but could include more, could include less. And the basic idea is not to outlaw exploratory research and not to say you can explore, but then you kind of have to own up that this isn't how I was planning to do it. Because I registered what I plan to do it, and anyone in the world can go look that up, including journal editors and reviewers, but other research consumers. And so it doesn't say that you can't do it, but you should then say, we did some exploring and we found that out. And then readers know that that's exploratory as opposed to the confirmatory research and how you plan to do it. So the big criticism of pre-registration is that it's a prison and it binds people into doing things a certain way research takes different twists and turns as you go. We should be able to kind of roll with that a little bit. And you can, but when you deviate from what you plan, you kind of need to own up to that a little bit is the basic idea.
How much this concept can help in the tenure process as well. Mary and I met this morning with a group of new faculty, very stressed about tenure and publishing. And how documenting what you're doing and where you are in the process could help people understand as you go through. As opposed to listing 8 in progress, what's the not even in progress or the yeah.
That's a lot
that
of
you
in-progress
actually-
work.
Yeah.
Right. That you have concrete
and you
plans out there.
document it.
It's a good point. How this plays out, especially for junior faculty in all these things, is a really interesting point of discussion. The primary idea behind pre-registration is to reduce researchers' degrees of freedom or researcher flexibility and say, well, if you said this is the best way to do it, then do it that way. You don't get to try every possible way, and then if you find one way to generate statistically significant findings, that's what you report. So natural experiment, it was some weird federal institute, the National Institute for Health, Blood, Lungs, and something institute. That is not what I do. But pre-2000, they're funded projects. And so this is kind of counterintuitive for me, but this is risk, a relative risk index. And so negative or smaller findings are more positive because they're reducing the risk. And so the pluses are statistically significant findings. So most of the federally funded studies were reported statistically significant results. Some null effects. These are null effects. In 2000, when they said you have to pre-register as a precondition of funding, only 2 studies reported benefits. Most reported null effects. 1 study actually reported harm when they analyzed it the one way that they planned to do it, as opposed to doing it however they wanted and reporting it as if that's the one way they did it. So this is just one example on the Open Science Framework. This is a draft for registration where you just start filling in these different areas. And so this is one of their templates that asks you what's your study design, how are you going to sample, what are your variables, how are you going to analyze, and then another. It's relatively straightforward when you put it up there. It does shift your kind of workflow. You got to figure all this out beforehand. You can't just have a vague idea, collect some data, and figure it out. You've really got to spell it out. It's actually very nice to have that all spelled out beforehand once you do it. I'm just starting to do that. It's hard. It's different.
Is it exclusively for quantitative research?
It's a really good question. And so I'm actually writing a paper now that talks about doing this in how that might apply to single case design. There is a brand new study out, or a brand new paper out, looking at doing this with qualitative research. And there is a debate in the qualitative field whether and how this is appropriate to do for qualitative research. And I think it probably goes back to kind of your roots and epistemological views as a qualitative researcher, whether that makes sense or not. And I think for some folks it does, and for some it really doesn't.
You said there's a paper out though, even?
Yeah, and so I'll make sure that it
Okay.
very recently, it just came out like a month ago, and I think it's kind of the first one that makes recommendations for doing this in qualitative research. So open data, open code, open materials. So this is the idea of, you've got data, share it, open it up. Same thing for code. So this is your analytical code, how you analyze the data. And materials, the surveys that you used and developed, the protocols that you used with your research, just how you did all of that. So at one level, obviously it facilitates replication, but it also allows others to verify your findings. So they go in and do the same thing you said. Do I get the same things? But people can reanalyze your data. They can analyze the same research question in different ways, or they can do something totally different with that data. Why wouldn't we, going back to kind of Merton's norms, why wouldn't we want to get as much out of a data set as we can, not just what you can do or what you're thinking about during a particular time period? Help replication and help with synthesize. We can actually get that raw data and work on in a synthesis rather than extracting effect sizes. Lots of different data repositories are growing out there. Many of them have different specialties. So it's, I think it's Databrary they do more qualitative data, and they have a lot up there for putting up videos and different qualitative data. And so the difficult part about this is, how do we keep this anonymous? How do we keep it confidential? What about IRB consent? There's some growing guidelines for how to do that. And I really like these 2 articles, Levenstein and Lyle and Meyer. ICPR has some recommended language to use for IRB forms. And the general finding is, or the general good news is that we're very nervous about this, or people aren't going to want to participate in my study if I say I'm going to share it. Most people who are going to participate in a study, they want to have that research be as impactful as possible. So they tend to find that people are fine with it. You should de-identify that data as much as possible, and you can embargo availability of data. So maybe you're in a larger study and you're going to be writing this up and fooling with it for quite a few years. You can put a date and not make this available until such and such a date. You can also make it selectively available. So I'm going to embargo it for the general public until such and such a date. I'm going to let others with permission, such as journal reviewers, selected colleagues, access it before that. So the repositories are getting more sophisticated in being kind of selective about sharing. Open access, certainly a big one. So open access tends to cost about $3,000. It varies a lot depending on the journal. Some of them are free, but they tend to be very small scale journals that do this. But it's becoming much more common in education. Our field, AERA, the big educational association, just started an open journal, PLOS journals. I'm not familiar with this, but I looked up. It is the highest impact factor open access journal there is. It's like an impact factor of, I don't know, 60 or something. It's huge. So they can be very successful. And here's a link for the directory of open access journals. There's hundreds and hundreds of them across different fields now. But that's still under the traditional auspice of a journal. So one new direction, not new, but one direction, a different direction is with preprints. People still tend to call these preprints, but more and more often they're just being called papers, because it's not, preprint kind of implies that I'm going to post this before I publish it. Papers is more, I might never publish it. I might post this after I publish it. So it's just a different, it's posting a form of a paper that a journal doesn't own a copyright for, and you're making it publicly available. So typically this is a version of a paper before it's accepted, and different publishers have slightly different guidelines, and it's a little bit of a mess. And I should have put the link. There's a server, Romeo Sherpa Romeo. I'll look it up, but I can send it to you. And they have cataloged all the different journals' policies. I don't know if it's entirely up to date, but the journals are becoming more into this, and they're getting better at posting this information on their websites, but sometimes you have to really search for it. But before you submit a paper, it's yours. You can post it wherever. And so physics is a good example of a field. People are done with a study, they write it up and post it on a preprint server. It is available to anyone with internet access. That's just the common, that's business as usual.
Will they take it down when it's published?
Nope. So it's not, that's yours.
It's a different version that's going.
It's a different version that hasn't been formatted and hasn't received feedback from the journal. So that's yours. Where it gets into a gray area, so it's yours before you submit it. You can do whatever you want with it. It's not yours after it's been accepted and you've signed the copyright form. In between is the gray area where it differs by publisher, where it's been reviewed, so it's gotten feedback, but it hasn't been accepted. A lot of places, before it's been formally accepted, you can post it, even if it's received feedback. I think this is going to be really an evolving area for lawyers to kind of play out. But certainly, before you submit it, you have that copyright. You can put it up, and you don't have to take it down. There are certain journals who will say, if it's posted as a preprint, we won't accept a submission from it. Very few, but some of them do say that. The big objection to preprints is they're not peer reviewed. Anybody can put, most of them are moderated, but very lightly. And so you can post virtually anything on a preprint server. So it's a really caveat emptor thing. But given the vagaries of peer review, I don't know if that's such a huge problem. I mean, it is on one hand, but it demands that a skeptical, critical research consumer.
Can I ask, how is
Yeah.
that different than like an ERIC document?
So ERIC document is similar in some ways. So ERIC is the federal education repository where they require that grantees, and it's open access, so they require that grant-funded projects post their findings on ERIC. But it's controlled by the Department of Education, and it is something, if I wanted to post something that wasn't, I don't know if I can still just post something to ERIC if it isn't a funded project. But if I did way back when, there is some level of, it's not exactly peer review, but they look at it. It in essence, it is similar to, it's very similar. And so there's lots of things that are vehicles for this. The preprints are a little bit, tend to be more wide open and just their electronic space, post everything up there, and let's kind of crowdsource. And some of them do allow for open peer review. And so anyone can leave comments and reviews. And so that's kind of the public record of it. So it has a form of review.
We're
out
seeing
there.
that we have a tool we're using called Hypothesis.
Yeah.
That people are using
Yeah.
around to try to do the online commenting and
Yeah.
peer review process early on. But they're doing it more in just a real collegial way, like,
Right.
hey, I'm about to submit this.
And so it can be used in that way, right? For feedback. I'm about to
Yeah.
submit this. What do you think? Where should I submit it? Type thing.
And then-
It can also be 2 years down the line. I read this and there's a flaw in your analysis. It can look a lot of different ways. But the preprints or the papers are really growing. And so there are some general preprint repositories. There are a lot of them, and there's a ton of them. I didn't want to list them all here on. But I'm working on one we should have up pretty soon for specific to education, Ed Archive. But I guess this archive with a capital X has become very popular. But, and some preprint FAQs and 10 simple rules to preprints. But preprint's not hard. I mean, you just click a button, upload it, title it, list the authors, and it's there. It gets a DOI. You can put keywords in so it's searchable. And so it's available to anyone with internet access, and it really, I think, is one potential way to combat publication bias. There's no editor or reviewers to poo-poo a study with no results. You can post whatever you want up there, and it's easily findable by anyone. We're running late, so I'm not going to spend much time on this, but there's green or gold, totally open access. Green means you can post. Green is more like the preprint server. Bronze is very limited, but there's these different levels of access, and over time, a greater proportion of studies. There's more and more access to more and more studies. There's still the majority. They're all behind a paywall here in the closed, but more and more, or at least some level of access to. So there's something they call the open access advantage. And I read about this and knew that generally, so with green access, with hybrid access, which hybrid is like, it's in a traditional journal, but you've paid or the publisher has decided to make that an open access article within a non-open journal. So those tend to get cited much more. Interesting that the gold, which is completely open access, has the lowest citation rate of all. And I hypothesize because a lot of open access journals are almost open access because they're so small and there's almost no overhead to them. And so there's just things no one's aware or outside of 12 people that it's a journal. And so it just doesn't get cited hardly at all. But these other levels of openness seem to enhance citation rate a lot, which is one of the things we're trying to have people think about and say, it's not only good for science, it can be good for you, which makes a lot of sense. If it's open and anyone can access it, it's going to have greater impact in real world impact, but hopefully reflected in citations as well. So here's a guide to when you post a preprint, you have to decide what type
We're
of
doing a Creative Commons certificate course right now.
yeah. So what
Some I don't know, Brian.
what level? What type of license? We just did a paper where we made it CCO, and I'm just learning about all of this stuff too. But so when you put a preprint up there, you can license it so that which dictate how people should reuse it, whether and how they should reuse it, basically. So I'm not going to spend much time on open review other than to say that I think it's a really interesting idea and that it probably the best known. Open review is the most nebulous, most kind of, that's weird, huh? And there's just, there are lots of different weird ideas with open review. One of them is unblinded reviews, where it's not masked. And so you can do it in any combination. So the reviewer might know the author, or the author might know the reviewer, or they might both know each other, or know their identities at least. One of the ones that I think is very promising is publishing the reviews. It's a really strange system where we do put all this time and energy into doing the reviews, and no one but the author and the journal editor ever see it. Wouldn't it be instructive for the research consumers to see what the reviewers said? We don't have that. That maybe could be posted. And then this idea of ongoing post-publication review. We have 3 people review this, and that's it. No one ever, we might, actually, sometimes people point to Twitter as probably the broadest type of ongoing post-publication review. When a paper might get hot, people are tweeting about it, and what about this, what about that? There are proposals that we should do things kind of like an Amazon type review, where we have, for different methodological elements, crowdsource it, and you rate out of 5 stars. What is the sampling procedure rate? And so you come up, that's a 4.6 method set, 4.6 stars method section. Wow, pretty good. There's even discussions of having reviews be citable products that count. And so you can get like likes on your review and things like that, where it actually becomes something. I do a lot of reviews. I get basically no credit for that. And so so a lot of ideas going on with that. Registered reports is in some ways a reform around review, and it kind of draws on pre-registration. And so the idea, I think I'm going to skip ahead to try to explain what it is a little bit. So the idea behind registered reports is you develop your idea for a study and you design your study. At that point, once you write up the intro and the methods, that's what you submit to a journal. And so it is reviewed based not on the findings. Did you get interesting findings? Did you get statistically significant findings? Just on the quality of the study design. And it's before you conducted the study. So the review isn't just after the fact, and you should have done it this way. What are you thinking? It is, well, do you think you could do it this way? So it's much more of a negotiation between the reviewers and the author.
What a great way to bring on new researchers.
It makes so much sense. So when if it gets through that stage and the kind of negotiation comes to where this is going to be a good study, it gets in principle acceptance. At that point, you pre-register your study. You say, this is how we've decided we're going to do it. You conduct the study, you analyze the data, you write the report, then you resubmit it as stage 2. Stage 2 review is just, did you do what you say you were going to do? And if you did, and you reported it appropriately, doesn't matter what the findings are. It gets published. You can do exploratory research, but it kind of has to be justified and approved. And then it's published. And this is becoming, I'm doing a special issue on registered reports for remedial and special ed. Gifted Child Quarterly just started accepting registered reports, and Exceptional Children, informally, not official, but is moving strongly towards doing this as an option. So in our little field, but in other fields, it's becoming more and more common. 156 registered reports have currently been published, although many more have been accepted in principle. And this is like in all of science, everywhere. Center for Open Science tracks this. And but many more have been accepted or in press. And 167 journals are currently accepting registered reports, many of them just for special issues, but are doing some form of registered reports. There was an article just last year that talked about this is the biggest innovation in scientific reporting since the advent of journal articles in the 1600s. That this is just we've been doing it basically the same way for 400 years, and that this is really a different way to think about how we do research. Registered reports are associated, not unlike the pre-registration thing that we saw, of the registered reports that have been published so far, approximately 60% have reported no findings, which is about 6 times as much as in the general literature. So just a very different approach with different results. So this is just a screenshot of, it's actually a journal that it's kind of an online journal, but it's really more of a preprint journal, and F1000 research. And so they have open peer review. So these are the reviewers. Here are their identities for round 1. This person accepted it. These people did revise and resubmit. You click on the link and you can read their review. And then for the second round, then these people accepted it, and you can read their reviews here. And down below, it only gets one, has garnered 1 at this point, but here's the ongoing post-publication reviews where others can leave comments about the paper. Exciting stuff that online affords us, that we can do this now. This I like because I'm weird and I like this meta stuff. So this is an article about open peer review on an article on open peer review. All right.
Is there any evidence that, like, for requirements for tenure and such, that institutions are starting to accept these kinds of publications?
I wouldn't say there's evidence at this point. I've got some anecdotes that Brian Nosek, who's the director for the Center for Open Science, wrote a blog piece, and he said he gets asked to be an external reviewer, and he's starting to look at this stuff and really play that up. But mainstream, no, I don't think it is, and I think it's on here is one of these challenges and questions. So what do we do with hiring and tenure and promotion and these types of decisions? Are we hanging junior faculty out to dry if we encourage them to spend their time doing this and it doesn't count? I actually did a talk with some advanced doctoral students recently, and this came up, and I said, I think be savvy about it. I think doing some of this is great, but I wouldn't put all my baskets in a bunch of pre-registrations and preprints. That's just not going to carry the day. But so I'm on our college's tenure and promotion committee, and this year I'm looking at everybody's stuff, and it is just so easy, which is part of their popularity, to say, how many journal articles do they have? Let me look at those journals, and they've got, we're an R1 university, so they have the impact factor right there with the journal, and so that's a good journal. So that I'm using that as a proxy for study quality, but there's good research that says still the modal number of citations for any given journal, even the high impact ones, at least in our field of education, is still 0 or 1, and that the correlation at the article level to the journal impact factor is relatively weak. And so we use this because we're lazy, and I don't want to read all those articles and decide that's a really good study, even if it's a preprint or even if it's in a lower tier journal. I just look at so I think we can hopefully do more around looking at the quality of the work and of the science rather than its outlet. But in all honesty, at this point, I think most hiring committees, tenure and promotion committees, merit groups, it is still looking at, oh wow, you've got a lot of articles. And look, a lot of those are in these high impact factor journals. Good stuff, good work. And they don't read it.
Being able to document along the process though, so I look at it from like a mentoring standpoint, right?
Yeah.
And think of how much I learned at each stage of doing reviews and getting a revise and resubmit. So being able to document that as part of your learning, maybe it doesn't count for that final review, but in encouraging people along the process, it seems like we could define some value there that we don't currently.
Well, and some of these things, it'll be really interesting to see how this evolves. So one of the things that if reviews could become potentially a product,
Right.
but certainly data sets. So one of the things that people are into this talk about that your study shouldn't be the big impact thing that comes out of, or your publication shouldn't be the main product. It's your data. That carries so much more potential in terms of what others can do with it and how it can be combined with other data, that really the worth of a product might be how many times your data gets cited in the future, not so much your article. But it's gonna take a while to change because we're pretty firmly ensconced in that kind of counting up publications and impact, looking at impact factors. But it's a great question.
Speed, though.
I'm enthusiastic about it,
Platforms
but
are there now. They weren't there.
Right.
2 years ago, they weren't there.
Yeah.
Or if they were, they weren't publicly available or easy to find.
and just to wrap up, I think these are my last two slides here. Is no, they're not. I had a few graphics, but the only two like more with writing on it. This stuff does take time and effort. The registered reports thing to do kind of a prospective review. So how much is it worth the payoff? I don't know. Some of that's, I think, an empirical question. My kind of gut is it is. I don't know. Right now, these things are all just being developed, so there isn't a ton of clarity. I know a lot more about it than I did a year or two ago, but there are still things I don't know how to do this stuff. And I'll ask the people at Center for Open Science who are just great with this and great at answering questions. I asked them about the qualitative piece a little while ago, and they said, I don't know. We haven't done it yet. It's a good question. We don't. This is all kind of evolving to some degree. And then the culture and the incentive piece of it, and then especially around data sharing. But can we do that legally and ethically? And my general sense is we can a lot of the times. Maybe we can't for all data, and that's okay. And so leading to the last substantive slide with content. Center for Open Science took the lead with a big group of folks and came up with these transparency and openness promotion guidelines. And they're for different stakeholders, especially journals, but different stakeholders. It's 8 different standards, but what I really like about them is they have 3 different levels of implementation with this recognition that it shouldn't be all or nothing, and that we should be able to kind of dip our toe, do it, really do it type thing. And that's what they're encouraging. And I get this from them, this idea that perfect is the enemy of the good. That it's so easy to say, oh, I can't do everything, so I'm just not going to do anything. That some openness is not a dichotomy. Some openness is better than no openness. And so the more that we can do it, and I think like most things, you experiment with it. Oh, first thing I did is posted a preprint. That was easy. And look, I have 100 downloads on it that I wouldn't have gotten. That thing's doing pretty well. Good. Well, I can do that again. Now we're starting to pre-register. It's a little bit hard to figure out, but working with people. And now we've got a research plan that we're just going to implement instead of trying to, kind of figure it out as we go. Open science badges is one way that they're trying to kind of incentivize this. So Center for Open Science, I have some more content on this, but they give you a badge if you pre-registered your study, if you have open data, and if you've had open material. So you can get up to 3 badges that are electronically there with your article, and then you can have them with your kind of author profile as well. And so this is just an example for the top guidelines where the first level is disclosure. So you require people to say whether they did it or not. Did you share your data? Yes or no? You don't check, but you let them have a chance to say whether they did it or not. Level 2 is you say to publish here, you have to share your data with some exceptions, but you don't really check it. You just say you have to do it. Level 3 is you say you have to do it and you actually check it. If there isn't shared data, you don't publish in that journal. So this is it is not truly experimental, but they tracked one journal that implemented the top guidelines that started or giving badges for open data and before 2014. And so these are different issues of different journals, where the other journals did not see an increase in data sharing. The one that did the badges saw a steep increase. Mind you, this isn't at 100% up here, it's at 40%, but still move in the right direction. And that is it at long last.